talked about that constantness, that in Rust everything is constant. Is that right? Is that really true? Those of you have been programming for a long time might might have raised eyebrows in my last videos by saying, how could you say that? Is immutability the same as constantness? So that's the question. So I kind of specified in a very layman's way to basically point out the fact that the things are supposed to be fixed, but technically speaking, constantness could be slightly different from immutability, because they are not both the same concept. So in this video we'll talk about simple things like, another thing you saw is that when we say let x equal to 5, what does that mean? Is that assignment like in C or C++? So we'll find out what let does, and we'll also find out what is the scope in this video, the scope of a variable, and we'll basically talk about a very important concept from the last time that we learned, that in Rust everything is constant. But is constantness the same as, by default it's constant, we said in the last video, but is the constantness same as immutability? So let's look at it. So one thing we have to see is that in Rust is a very statically strongly typed language. That, what does that mean? That means types are known at compile time. Now there are other languages like Python and all, or for example, which are also statically, which are, I think they have a problem where at runtime they would like to know the types of the things, types of the variables, but but they don't have to have. So there are some differences. So you got to go and check out the difference between C, C++. C is also a statically typed language, but weak typing, where it allows you to do things like void star and things like that. So that is static but weak typing, whereas there are languages that let you do static strong typing, and there are other combinations too. You got dynamic typing, strong dynamic typing. I think that is what Python does. But anyway, I don't want to confuse you. This is not a course about Python and difference between languages. It's a course about Rust. So let's focus on Rust. And Rust is basically, it gives you static strong typing. That is important to know. That means variables are bound to a type with a value. Now that's what, let's look at. What does that mean? Why didn't I say variables are assigned? And we'll clear some of the confusion. I wouldn't say confusion, but kind of more nuanced understanding that the constantness is not the same as immutability. Immutability only says that variables are immutable by default. They're not always immutable, whereas constants are always immutable. So that's a very key difference that we have to understand. And if you want to also see, so yeah, so just we want to make sure. So we look at some programs this time, and what we see is, let's look at some of the simple programs this time, and we should say that, let's see that. So what did we write last time after the class was over? Just like you guys, I also went back and did some exercising. So let's look at some programs like variable binding, which is a very important concept. So here what do we have? We have a variable that is bound to I32 but no value is assigned. So basically x is uninitialized. Windings are supposed to be initialized. Now what you might think that you might be curious to know like what would happen in this program. When I have let x, I have defined the type but I haven't. So I bound the variable to I32, which is a type, integer 32, but I haven't given it a value. So if I have not given it a value, and in the next statement you say I'm printing x in println macro, what would happen? Would it print? Let's try to build this program. Rust C variable bindings. And what are we getting? We are getting a warning saying x isn't initialized, and then he's saying that you try to use a uninitialized variable. You say he's saying that x is uninitialized. So this actually is an error because if you had, on the other hand, suppose you had changed the value after this. Suppose what happened, even though now what is the difference between these two statements? One is let, one is just x equal to 12. So this is a variable, new variable binding, and this is basically an assignment. This is not a new variable, it's just you're working on the same piece of memory. So now let's see that if this one compiles, and it did compile. And so yeah, before the bindings have to be initialized with a value before you're allowed to use them. If you didn't have this, if you didn't have these two statements, no initialization here, not given a new value, and you didn't have println, and then what happens? I think it might just give you a warning in that case. Yes, and they said that you should have initialized it. So that's the difference we have to understand. That variable bindings and assignment. What's the difference between assignment versus variable binding? So after this, let's look at another example of scoping. What is scoping? Variables have a scope. So let's look at scoping. So we'll have a simple program. So variable bindings have a scope as well. So here, as you can see in this program, you can see that I started with a variable binding of x to I32 with a value of 17. And I tried to print that inside this block statement. I have another actually variable y. Now here, if I had, I think this will, let's see, let's try to compile this Rust C, and then I think it's better to go from errors to see what mistakes are made. He's saying, okay, that's now a very good example. Why did it give us this error? Why did it say that y is unknown here? In this scope, y is not there. Because as you can see, the y was actually defined only in this block in the middle. So because y was defined here, y basically disappeared here at this point. And then after that, you still try to use it in a println. You said the x is this, y is this. So I guess the bottom line of is that you got to know that variables have a scope, and you got to know whether a variable exists in that scope before using it. So we realized that the y stopped existing at this last brace, but we continue to use that. So I guess this is another important lecture on to understand a concept for us, that the Rust is block scope language. As we know, we have function scoping, we have block scoping, and some languages give you block scoping ability. So as you can see, the Rust is block scope language, which is good. Now let's look at another program in the scoping of variables. We see that what we did, we had a variable here, mutable. Now another important point from last video I would say is that when we said everything is immutable in Rust by default, this immutability, why did they do this? Why did they make it that way, that everything is immutable by default unless you specify, hey, your intent saying that this variable is immutable variable, it will change after it's created? Why do you have to specify that very explicitly? If you think about that, uh, how easy it would be to have a compiler design when you don't have this particular way of looking at things, that everything is immutable by default unless you make it mutable with the keyword mut. Because you see, this can be a machine can actually check that. But on the other hand, if you have like C kind of programming practices where you say, this is going to be a immutable thing, but it's just implicit in the sense that you're leaving it to the programmer to not violate those that statement or those conventions, that by default, without specifying the keyword, any particular keyword, you try to enforce immutability, it becomes much harder. So I think it's just that by specifying, by making everything constant, unless you specify, or immutable, unless you actually specify that it will change, it will be a typical variable that will change over the course of its life with the word mut. So that was the idea behind making immutability default and mutability a choice. And we shouldn't confuse immutability with constness, because const, as you know, const is not just immutable, but it's immutable forever. This is not just by default it's immutable. So that part also we have to understand. A variable is immutable by default, but you can choose not to make it immutable. Whereas const, no, you cannot choose. It's always immutable forever. It's more like, C++ has this const expression, which is evaluated at compile time, and it enforces that hey, this is a const expression. But they also have const, which is like you need not initialize it in the very beginning, but once you initialize, you cannot change after that. But that happens at more like runtime. But on the other hand, in C++, 11 and later, you have const expression, which basically at compile time you got to be able to evaluate that thing. So Rust is design choice of making immutability default rather than mutability default, which most of the languages do. In C and C++, most of the languages, when you declare a variable, unless you say const or something like that, you know that this variable, the reason it's a variable because it could change any. But it was harder to have the language deal with memory issues and things like that in a very safe way. So I guess Rust decide it's just a different way of looking at things. I was talking to a friend a long time ago, and he used to travel a lot, and he said in Japan and Germany everything is no unless it is explicitly said that it is allowed. Everything is not allowed. Nothing is allowed unless it is explicitly allowed. Whereas in other cultures, Anglo-based cultures, everything is allowed unless it is written it is not allowed. So it's just different way of looking at the things, like if you think about it, right? So anyway, so it's kind of helps us and um, to understand the mutability, the choice of the mutability being a choice rather than default by the Rust designers. So here, let's not get distracted, and let's see what is going on here. So as you can see, we have a variable x bound to I32 with value of 8, but then we start a block, we try to print x, then we assign, then we do another binding of x, and previous x basically disappeared. Now this can be a little bit, what is this? This is not just assignment of x and x being given a new value, it's actually a new variable. It basically shadows the previous x. So here if you print x, you would see it will give 12, not 8. But when you come out of this block, you see the x will go with the x that we define outside the block will be 8 again, and then x will change to 42. So that's a very important concept, and we have to be very careful about these things, about let versus just a pure assignment. And these things can sometimes bite us if we are not very careful. So in that, I came across this program which might be useful, Fibonacci sequence, which is a very popular starting newbie program in any language. I would say Fibonacci sequence, calculate Fibonacci sequence. As you know, Fibonacci is the sum of the previous two numbers. So here you see that how did we calculate Fibonacci? We said we have a function Fibonacci, which is like a typical Rust way of defining functions. Now we are seeing some new things. For example, we see that the argument is n32. Sorry, unsigned 32, u32. And I like Rust is a very explicit way of everything in Rust is very explicit. Like as you see here, I'm saying n is one of the mutable argument to Fibonacci function, and it has a type of u32. Not just a type being given, but a very specific way. I mean, u32 is also is there in things like C and C++, but it's kind of a type def or something, or it might be in some header file. But you can simply say unsigned int, but you don't know it is a 32-bit or is like 64-bit. But here you see everything is very explicit. You see u32. And then like in Python 3 style, you see that the function is supposed to return the u64, which is another very interesting thing. So now, what does this function do? If the passed argument is equal to 0, you return 1. Else you start by two variable bindings. So say two new variables, a and b, local variables to the function, and you say they have value of 1. Both are initialized to 1. And then we have a loop. So this is the first time we are seeing this keyword loop. We had seen let before in the last class, but loop is basically by default it's like infinite loop. It's like while one or style of some other languages. So it's like it's always true unless you basically get out because of some situation. So here you see it says if n equal to 1. So I guess since n is coming us at this point, we know n wasn't 0. Now n was some value, and it was obviously unsigned, so it's something positive value, and it's coming over here to us, and the loop will go on forever. But so we expect something to change, which will allow the loop to be exited, and that change is that n is being subtracted. So n is being subtracted. At some point n will become 1, assuming n was some positive number more than 1, and then when that happens you just return b. So if n equal to 1, you return b. Otherwise you calculate another variable next, which is a sum of the previous two, and then you reassign. You say a equal to b and b equal to next. And then you go back into that loop. And then before that you actually subtract n because you have to get out of the loop eventually. Now here you see why I bring up this point. I mean, calculating Fibonacci is not our goal here. Our goal here is to get familiarized with Rust is eccentricities, which are actually useful for us, some of these eccentricities. So as you can see, he's saying you can't do things like, in Python, I think this is more like Python style, where you can say, like if you think you could do something like let a be equal to b, it won't work because the let statement introduces new variables, and these variables will go out of scope before the next iteration begins. So on the next iteration, ba plus b will still have the original value, but let ab has introduced basically new variables. So basically bottom line is you got to know that let introduces new variables, new bindings. So should be very careful between variable binding let versus non-let, which is more like an assignment. So here, as you can see, we calculated Fibonacci sequence from 1 to 11. So let's see what is the Fibonacci sequences for. If we say rush C, well, it gave us some warning. It said that you never use that. You have a, so another thing you are seeing from yesterday's video and today's video is the Rust compiler is very helpful, and it gives us very useful warnings to say that hey, um, there is an unused variable or something like that, and rather than implicit things happening or leaving things to programmers discretion, here things are enforced, and compiler actually warns you or gives you error. So let's see what he's saying. He's saying you have a variable but you never use it. So what did we do? All right, so this problem is coming because we have this x bound to u32 with a value of 10, but we never used it, so there's no need. So let's comment that out. And I like Rust's way of commenting things out, because same as the C++ way, and also in C nowadays. So that doesn't change any new habits for us, which is good. So in any case, now as you can see that it gives us the Fibonacci sequence. But the lesson from this particular little Fibonacci sequence program was that be careful with let, introducing a variable with let, or just giving a new value to variable. It's not the same thing. It's a very subtle point, and that's why I wanted to bring that up. So now we have looked at assignment versus variable bindings. We look at scope. We looked at scope. So now what is, and we also clarified the distinction between immutability versus const. And then we said that look, even though we said, just to draw attention in the last video, that everything constant by default, you have to be a little bit more careful with the terms here. So we see that constness is, strictly speaking, different from immutability, because const aren't just immutable by default, they're always immutable, whereas variables are immutable by default. Regular variables are immutable by default unless you make them mutable with the mut keyword, mute. So you got to keep that in mind. We will not go into other aspect of const and const expression, things like that. So here, if you just wanted to be very, you see, hey, is there a const keyword also even after having all this mute? Yes, there is actually. So as you can see here, he uses this const 3 hours in seconds, and he says it's a u32 and it has this value. So in this case, this is not that later on you can't hear, there's no option to here say it is immutable. Like if it was a variable, imagine if it was a variable, you could say, but then variable could change after that. Like you have, in order to say that hey, it could change, you have to say mut, but by default it's immutable, but const is always immutable. So you got to understand different. So even though we said that in Rust everything is const, actually what we meant was everything is immutable by default unless you make it mutable. So we made some things clear. We got some new concepts. We understood things like the binding versus assignments. So I think we should stop today, and tomorrow we will see some differences between Rust and other languages in terms of the way of looking at object-orientedness. Even though a lot of concepts are similar, but we will see that Rust has slightly different way of implementing the same concept. And I just want to, as a um, kind of introduction, a little hint on what we will cover in our next class. I just wanted to show you things like you would see things like the new keywords like struct, implement, IMPL, and traits. And we will see that in our next class. But for now, today, understand that immutability, the little distinction between immutability and constantness, and also understand the difference between variable binding versus assignment, and what does let do. Let always introduces a new variable binding, and understand how do we give type to a variable with the colon and then the type syntax we understood. But in the next class, we will look at things like this little bit object oriented concept, which many of you might be familiar with already. But Rust has a different, slightly different take, a slightly different way of doing things. So we'll look into that, and stay tuned for our next video. And I'll see you guys in the next video. I hope you will have a very happy programming experience in Rust.